Hi everyone, welcome to today's tutorial. So I'm going to be solving this question on the screen today. It says determine the extension in the two ropes attached to a rigid, attached to the rigid supports in the system shown in the figure 5.134. If if the supported blocks are in equilibrium. Yeah, so this block here, there are also other questions. That's why the question says blocks. Yeah, so I'm going to solve these other questions after I solve this one. So when you look at this question, we first have to draw the free body diagram for the question, which is just going to be like this. Let me just write it properly. Okay, so the free body diagram will be like this. Let me start with the block, and then there's this force which goes this side. So this force is 100 newtons. Then we also have this other force which is going this side. Yeah, so this is how it is. So I'm going to name this tension as T1, then this one as T2. So now we are going to express T1 in two components, and then we add them to the other components, which is T2 and 100 newtons. So I'll start with the forces in the x. So say all forces in the x are supposed to add up to 0. So we've been given the angle here to be 30. So if we extend this and make a triangle, we make a 90 degrees here. So we're going to have our 30 there. So if we take the forces in the x, we're going to have T2, which is facing this side. It's facing towards the negative, so meaning we're going to have negative T2. And then we have T1, which is facing towards the positive. And of course the x component of this T will be, since this is the adjacent and T1 is the hypotenuse. So from SOHCAHTOA, you can agree with me that from SOHCAHTOA we're going to use cos, because cos is the one that has the adjacent and the hypotenuse. Hence we're going to say cos theta, which is 30 in this case, is equal to the adjacent, which is t, which is t in the x, and then everything divided by the hypotenuse, which is T1. So T1 in the x, everything divided by the hypotenuse, which is T1, yes. So from there, when we do the cross multiplication there to find Tx, which is just T1x, which is just the tension 1 in the x component. When we cross multiply, we're going to have T1 cos 30, of course. Our angle here is 30. So I'm going to add this to, this one will be positive because it's facing this side. So I'm going to have T1 cos 30 there. And then, do we have any other force in the x? No, we don't. So we say this is equal to that 0. So we make T2 the subject. So T2 will simply just be equal to T1 cos 30 when you take T2 to the other side of the equal sign. So from there we can also take all the forces that are in the y. So the forces in the y, they are also supposed to add up to 0. So the forces in the y that we have on this question, we have 100, which is facing down, so I'm going to say negative 100. Then we also have the y component of T1. So the y component of T1, we have, I'm going to say it's facing up, so it's going to be positive T1 in the y. And then the other y component, we don't have the we don't have any other force in the y, so we say this is equal to 0. So negative 100, we take it that side, so I'm going to have T1 in the y is equal to 100. But remember, this is a component, so we have to express this into, we have to express T1 into a y component there. So since in the x we used cos, in the y is going to be T1 sine 30. So we have T1 sine 30 there is equal to 100. So when we divide by sine 30, then we divide by sine 30 even this side, T1 will therefore just be equal to, so when we say 100, divided by sine 30. So it's 100 divided by, right, so T1 will therefore be equal to 200 newtons. So T1 will be 200 newtons. So let us now find T2. So T2 is given by this formula. So just replace T1 while there's T1 there. So to find T2, we're going to say T1 cos 30, which is just 200, which is T1, and then we say times cos 30. So T2 will therefore equal to, so T2 will therefore be equal to 173.2. So 173.2 newtons. So this is the tension 2. This is the tension in the rope number 2, which is this one. Oh, this one I named it as T1, and then this one as T2. So the tension in this rope is 173.2. Then the tension in T1 is 200 newtons. Alright, so all those that have not yet subscribed to the channel, make sure that you do so. We have found the answer to the answers to this question. Let us quickly move on to the next question. Okay, thank you very much for watching. See you in the next tutorial. Make sure that you don't forget to subscribe.